Hello. Hi everyone. Today I'll be doing a small demo, a progress report on my quadcopter project. So as you can see, this is the quadcopter as it stands right now. Notice that there are no wires for power or for internet connection going to it. We have here a full stack, which you can see consists of the battery level, the platform level, the BeagleBone level, and then the battery cape, and then on top of that, finally at the very top, the proto board. And on the side here, you'll see that blue light over there flashing, and that is the wireless Wi-Fi dongle. So it's connected to the local Wi-Fi, and here you can see the system lights for the BeagleBone. And then these four things going up to the top connect the electronic speed controllers, which are these things, which drive the motors, and they connect them with 3 wires to the proto board, and then the proto board then routes the right connections to the GPIO pins for the signals. And so right now what the board is doing is it's controlling all 4 motors with just a heartbeat, and we're going to go over here to our desktop computer where you see that also notice that whenever the quadcopter boots up, it emails me its IP address, and you can see here it says your IP address is this, and so we go over to the terminal and we try to SSH into it, right, like so. So we're going to type in the password, which is like so, and once we do, and we should be able to get on. We'll give it a, okay, there we go. Okay, so we're in. So effectively, whenever you have a terminal and you're on the same network as the quadcopter is, you have a controller. And I'll demonstrate that by doing this. And you'll see that it's Ubuntu that's running on it. So you'll see that it has a whole bunch of files on there, and we can request root privileges. And once we do that, we'll be able to run the commands to power the quadcopter. Okay, so the command here is Python, and then the command is fly test. And you give it 2 arguments. You give it the duration of the thing, and you give it the speed. Now speeds that turn the motor are 6 or above, but to just silence the motors, you enter it with a speed of 4, which is the default. So what this is saying is I'm going to want the quadcopter to shut off its motor, or to set its motors to ready state, but not spinning, for 5 seconds. So 5 is the number of seconds, and then 4 is the speed, the default speed being not turning at speed 4. So once I press this, it says set globals, and you see all 4 motors are done. And so after 5 seconds, it clears up and it does that. So now we can enter a even faster speed. I'm just going to change this last guy from 4 to 8, and we'll see what happens. Okay. Now with the 8 speed, I'm kind of scared, so I'm going to take the safe route, and I'm just going to do it for 3 seconds. Okay. So let's go over to the quadcopter, and once we type in enter here, let's see what happens. Okay. Okay. So you'll see that the quadcopter, 2 of the motors were spinning quite fast. that was 8, and it goes all the way up into like 55 or I don't know whatever it is yet. I haven't been brave enough to try, but you'll see that it went so fast that one of the motors actually spun off, and we'll have to. That means I didn't secure it tightly enough. But all 4 motors were spinning. I think maybe I've been having issues with this motor. Something wrong with the wiring connection over there, where it's not getting the signal from the computer to spin. So we saw that 3 motors were spinning at the speed that we expected, and you see that the quadcopter was getting enough speed to be able to move a little bit. So ideally, I'm guessing that if I turn the speed up to like about 15 or 16, it will be able to lift off. But I don't want it to like hit me or anything, so I'm planning to take this out to a wide open space. Now, the future is now in a few days, or actually tomorrow, I'll be getting another component for this device, the last piece of the puzzle, as it were, which is a pair of receiver and transceivers, or transmitters, a transmitter and a receiver. And the receiver will be mounted on here, and the transmitter will be mounted onto my computer. And so I'll be able to control this guy without just using Wi-Fi. So what will happen is, mounted on this platform on the top is an additional component, which is the receiver. And the receiver will then receive signals from the transceiver, which has a range of about a couple of miles, like 6 miles. And when it gets a signal from the transmitter, it will then pipe down and it will run these commands, on the computer. So that's the idea. So that way, I can take this out into a park somewhere, or someplace open and not so indoors, so I'm not limited to indoors, right? So I can actually really start testing this guy out. So my plan is to figure out how to wire those components up this weekend, and then take it out to Gasworks Park and try it out. So I'll bring my laptop, and I'll have the transmitter attached to it, running via USB, and then I'll have the receiver mounted on this guy, and it'll be receiving signals, and once I'm able to do that, then we should be able to fly this thing outdoors. So, there's been a lot of progress thus far, and I'm moving at a very fast rate with developing this thing, and I hope to get it up into the air, within the next couple of weeks. So thank you for watching this video, and I'll update you very soon. Alright, bye.